In the deep ocean, being seen can be a death sentence. There are no forests to hide in, no rocks to shelter behind, and nowhere to run when a predator appears. Yet somehow, countless creatures manage to vanish completely. Some become transparent. Some turn themselves into living mirrors. Others create their own light or become darker than darkness itself. The deeper you go, the stranger camouflage becomes. But how far can evolution really take invisibility? Camouflage is one of the oldest survival strategies on Earth. In forests, animals hide among leaves and branches. In deserts, they blend into sand and rock. But the ocean presents a unique challenge. Much of it is open water, an environment with very few places to hide. Out here, survival often depends on becoming invisible. Near the surface, sunlight floods the water. At first, this seems like a good thing. Bright conditions make it easier to find food, navigate, and avoid obstacles. But sunlight creates a problem as well. It makes everything easier to see. Predators patrol these waters constantly. Tuna, dolphins, turtles, and countless species of fish are always searching for their next meal. Any animal that stands out quickly becomes a target. So, evolution found an extraordinary solution: transparency. At first glance, the idea sounds simple. If predators hunt using sight, then becoming see-through should make you harder to detect. But in reality, transparency is one of the most difficult forms of camouflage to achieve. Most animals are filled with structures that make them visible. Muscles, organs, blood vessels, and pigments all interact with light. When light strikes these structures, it reflects, scatters, or gets absorbed, revealing the animal's presence. To become transparent, an organism must minimize all of these effects. Few creatures do this better than jellyfish. Many jellyfish are composed mostly of water with relatively simple internal structures. Because their bodies closely match the optical properties of the surrounding seawater, light passes through them with very little distortion. The result is remarkable. Even when a predator is only a short distance away, the jellyfish can be surprisingly difficult to see. And jellyfish aren't alone. Many fish begin their lives as transparent larvae drifting through the upper ocean. At this vulnerable stage, they are small, weak, and easy targets. Transparency provides a crucial layer of protection while they grow. Some species take this strategy even further by concentrating their developing organs into compact areas of the body. By reducing the amount of visible tissue, they remain transparent for longer and improve their chances of survival. But transparency is never perfect. Eyes, digestive systems, and other essential organs often remain visible. Every animal faces trade-offs between functioning properly and staying hidden. Still, for millions of years, transparency has proven incredibly effective. It's the first major step toward invisibility. Yet, as successful as transparency may be, it only works where sunlight exists. The moment light begins to fade, a completely different strategy takes over. Because farther below, some animals don't try to disappear by letting light pass through them. They disappear by reflecting the entire ocean back at whoever is looking. Transparency is an incredible way to disappear, but it has limitations. As animals grow larger and develop more complex bodies, remaining completely transparent becomes increasingly difficult. Organs become more visible, muscles become denser. Eventually, many creatures need a different solution. In the upper layers of the ocean, evolution found one. If you can't become invisible, become a mirror. Imagine a school of sardines moving through sunlit water. Thousands of fish swim together, their silver bodies flashing as sunlight strikes their scales. At first glance, this seems like terrible camouflage. Surely all that reflection would make them easier to spot. But the reality is far more surprising. For predators hunting nearby, those flashes can become incredibly confusing. A predator approaching from the side doesn't necessarily see the fish itself. Instead, it often sees reflections of the surrounding water, the sunlight above, and the environment around the fish. The animal's outline begins to break apart. Rather than appearing as a clearly defined target, the fish blends into the constantly shifting light of the ocean. This strategy is known as silvering. It's one of the most successful camouflage techniques in the sunlit ocean. The secret lies beneath the scales. Many silverfish possess specialized reflective cells that act like microscopic mirrors. These structures reflect ambient light with remarkable efficiency, helping the fish match its surroundings from multiple viewing angles. The effect is so effective that even large schools can become surprisingly difficult to track when they move through bright water. And fish aren't the only animals using this trick. Many marine species have evolved reflective body surfaces that help scatter or redirect incoming light. Some shrimp larvae possess reflective tissues around sensitive areas of their bodies. Other species use mirror-like structures to disguise their eyes, often one of the most visible parts of any animal. This highlights an important truth about ocean camouflage. The goal isn't always to become invisible. Sometimes it's simply to make recognition more difficult. Predators don't need to see every detail. They just need to identify a target. If camouflage can disrupt that process for even a fraction of a second, it can mean the difference between life and death. And in the ocean, where attacks often happen at incredible speed, those fractions of a second matter. For millions of years, silvering has allowed countless species to survive in waters flooded with sunlight. But eventually, sunlight begins to weaken. As animals descend deeper, the bright world above slowly fades into a dim blue twilight. And in that strange in-between realm, mirrors stop working. Because once predators start looking upward at shadows against the fading light, reflecting the environment is no longer enough. To remain invisible, some creatures are forced to attempt something that sounds impossible. They start producing light themselves. As we descend beyond 200 meters, the ocean begins to transform. The bright, colorful world of the surface fades into a dim blue twilight. Temperatures drop, food becomes scarcer. The sunlight that once illuminated everything now struggles to penetrate the water. This is the twilight zone, a place caught between light and darkness. For animals living here, camouflage becomes much more difficult. Near the surface, transparency and reflection work well because sunlight is abundant. But in the twilight zone, a new problem emerges. Predators below can look upward and spot silhouettes moving against the faint glow filtering down from the surface. Even if a fish is transparent, even if it's reflective, its shadow can still give it away. For many animals, this creates a deadly dilemma. Fortunately, evolution found an astonishing solution. Instead of hiding from light, some creatures learned how to create it. This adaptation is known as bioluminescence. the production of light through chemical reactions inside the body. Across the deep ocean, thousands of species possess this ability. Some use it to attract mates, others use it to lure prey. But in the twilight zone, many animals use light for something even more remarkable. They use it to erase themselves. One of the best examples is the hatchetfish. At first glance, it appears unremarkable, small, silver, and easily overlooked. But hidden along its underside are rows of light-producing organs called photophores. When danger approaches from below, the hatchetfish activates these organs and produces a soft blue glow. The effect is extraordinary. By matching the faint light coming from the surface above, the fish eliminates its silhouette. To a predator looking upward, it no longer appears as a dark shape against a brighter background. It simply disappears. This strategy is called counter-illumination, and it may be one of the most sophisticated forms of camouflage ever evolved. What's even more impressive is that many species can adjust the brightness of their glow in real time. As environmental conditions change, they continuously fine-tune their light output to maintain the illusion. Some fish even possess specialized sensors that monitor incoming light and help calibrate their camouflage automatically. It's biological engineering at an extraordinary level. But not every creature produces its own light. Some recruit outside help. The Hawaiian bobtail squid, for example, forms a partnership with bioluminescent bacteria. These microscopic organisms live inside special organs within the squid's body, producing the glow needed for camouflage. The relationship benefits both sides. The bacteria receive food and shelter. The squid receives protection. Together, they create an invisibility system neither could achieve alone. For millions of years, counter-illumination has allowed animals to survive in one of the ocean's most dangerous environments. Yet, even this strategy has limits. The deeper you go, the less sunlight remains. Eventually, the faint glow from above disappears completely. And when that happens, producing light stops being a way to hide. It becomes a way to get noticed. In the darkness ahead, every flash can reveal your position. Every glow can attract a predator. Which is why the next great camouflage strategy does the exact opposite. Instead of creating light, these animals absorb almost all of it. At around 1,000 meters below the surface, the last traces of sunlight disappear completely. There is no sunrise here, no sunset, no moonlight, no stars, just endless darkness stretching in every direction. This is the midnight zone, one of the most hostile environments on Earth. Temperatures hover just above freezing, food is scarce, and the pressure is crushing. Yet, despite these conditions, life thrives. The challenge is that darkness changes the rules of camouflage. In the twilight zone, animals could hide by matching the faint glow from above. But down here, there is no background light left to blend into. Producing light no longer helps you disappear. In fact, it often does the opposite. Many deep-sea predators use bioluminescence to hunt. A flash in the darkness can reveal the location of prey from surprising distances. In an environment where visibility is already limited, even the smallest glow can become a dangerous mistake. This forced evolution to develop a completely different solution. Instead of avoiding light, some animals learned how to absorb it. Meet the anglerfish. Few creatures better represent the strange nature of the deep sea. Suspended above its mouth is a glowing lure that attracts curious prey. Small fish and crustaceans see the light and move closer, unaware of the enormous jaws waiting in the darkness. But the lure is only half of the anglerfish's strategy. The rest of its body is covered in skin so dark that it becomes almost impossible to see. Scientists call this ultra-black coloration. Unlike ordinary dark skin, ultra-black skin absorbs nearly all incoming light. Rather than reflecting light back toward an observer, the surface traps it, preventing it from escaping. The result is extraordinary. Even when illuminated, the fish appears almost featureless. Its outline becomes difficult to distinguish, making it look less like an animal and more like a hole in the water. Several deep-sea species have evolved similar adaptations. Researchers studying ultra-black fish discovered that their skin contains densely packed melanin structures arranged in ways that maximize light absorption. Any light that enters the surface is scattered repeatedly until almost none of it escapes. It's essentially a biological version of one of the darkest materials ever engineered by humans. And in the deep sea, it provides a huge advantage. Predators can hide their bodies while exposing only their glowing lures. Prey sees the light, but not the hunter attached to it. It's one of the most effective ambush strategies in nature. Yet, even ultra-black camouflage isn't the strangest solution evolution discovered. Because farther down, another color begins to dominate. A color that should make animals stand out instantly. A color associated with warning signs, danger, and attention. Red. But in the deepest parts of the ocean, red doesn't make animals more visible. It makes them disappear. On land, red is one of the most visible colors in nature. It's the color of warning signs, flashing lights, and poisonous animals advertising that they should be left alone. Red demands attention. If you wanted to stay hidden, it would seem like one of the worst colors you could choose. But the deep ocean plays by a completely different set of rules. As sunlight travels through water, different colors are absorbed at different rates. Red light disappears first. Even at relatively shallow depths, very little red light remains. Descend farther into the ocean, and it vanishes completely. This creates a fascinating illusion. Objects only appear red because they reflect red wavelengths back to our eyes. Remove those wavelengths, and the color effectively disappears. The deep sea, where red light no longer exists, a bright red animal can appear black. And black in the darkness of the deep ocean is excellent camouflage. One of the most remarkable examples is the blood belly comb jelly. At first glance, it seems like a contradiction. Parts of its body are transparent, yet its stomach is a deep crimson red. Why would an animal that depends on camouflage carry such a noticeable feature? The answer lies in what it eats. The blood belly comb jelly feeds on bioluminescent organisms. Many of its prey continue glowing even after they've been swallowed. Without some form of protection, every meal would light up the jelly's stomach like a lantern, instantly revealing its location to predators. Evolution solved the problem with color. The red pigmentation absorbs and conceals the glow, effectively hiding the light trapped inside its body. What would have been a deadly weakness becomes invisible. And the blood belly comb jelly is far from alone. Many deep-sea shrimp, fish, and crustaceans have evolved red coloration for the exact same reason. In the upper ocean, these animals would stand out immediately. In the deep sea, they practically vanish. It's one of the most counterintuitive camouflage strategies in nature. The very color that attracts attention near the surface becomes one of the best ways to avoid attention in the depths. By now, evolution has already produced transparent animals, living mirrors, biological flashlights, ultra-black predators, and creatures that disappear by turning red. It seems impossible for camouflage to become any stranger. But some animals don't rely on color at all. They rely on deception. Instead of blending into their environment, they convince other creatures that they're something entirely different. And in the ocean, some of the greatest survivors are not the best hiders, they're the best liars. Until now, every camouflage strategy we've explored has followed the same basic principle. Blend into the environment, become harder to see, match the background. But some ocean creatures discovered a completely different approach. Instead of hiding, they pretend. This strategy is known as mimicry, and it allows animals to survive by convincing predators, prey, or even other members of their own species that they are something else entirely. One of the most beautiful examples is the leafy sea dragon. Found along the southern coast of Australia, it resembles a drifting piece of seaweed, far more than it resembles a fish. Leaf-like appendages extend from its body in every direction, while its colors perfectly match the surrounding vegetation. Even its movements contribute to the illusion. Rather than swimming like a typical fish, it gently drifts with the current, mimicking the motion of floating seaweed. To a predator, it doesn't look like food. It looks like part of the landscape. Other animals take mimicry in a far more deceptive direction. On tropical coral reefs, cleaner wrasses perform an important service by removing parasites from larger fish. Over time, reef animals learn to trust these tiny cleaners, allowing them to approach without fear. But some species saw an opportunity. The false cleaner fish evolved a body shape, coloration, and behavior almost identical to the genuine cleaner wrasser. Larger fish approach expecting help, only to discover the mimic has very different intentions. Instead of cleaning parasites, it takes a quick bite of scales or skin before darting away. It's camouflage weaponized as a scam. Elsewhere on the reef, the black saddle filefish performs another remarkable deception. It closely resembles highly toxic pufferfish that predators have learned to avoid. By copying the appearance and even the swimming behavior of these dangerous fish, the harmless filefish gains protection without producing any toxins of its own. The strategy is brilliantly simple. Why evolve powerful defenses when you can borrow someone else's reputation? The deeper scientists look into ocean ecosystems, the more examples of mimicry they discover. Again and again, evolution arrives at the same conclusion. Sometimes hiding isn't enough. Sometimes survival depends on convincing the world that you're something you're not. And yet, even these masters of deception are outclassed by one final creature. An animal so extraordinary that it doesn't imitate just one species. It can imitate many: sea snakes, lionfish, flatfish, jellyfish, and it can switch between them in seconds. If camouflage is the art of disappearing, then this animal may represent its highest form, the ultimate master of disguise. For centuries, scientists believed they had a reasonably good understanding of camouflage. Animals could blend into their surroundings, mimic other species, or hide using specialized colors and patterns. Then, in the shallow waters of Indonesia, they discovered a creature that seemed to break all the rules. the mimicoctopus. Unlike most animals that rely on a single camouflage strategy, the mimicoctopus can switch between multiple disguises depending on the threat it faces. Imagine being confronted by a predator. Most animals have one response: run, hide, or fight. The mimicoctopus has another option: become something else. If threatened by a predator that fears venomous sea snakes, the octopus can pull 6 of its arms beneath its body while extending 2 others in opposite directions. Black and white bands spread across its skin, creating the appearance of a sea snake moving through the water. The transformation happens in seconds. Faced with a different danger, it may flatten its body against the seafloor and glide across the sand like a flatfish. In another situation, it can spread its arms outward and display warning patterns that resemble a lionfish. What's remarkable isn't just the disguise itself, it's the apparent decision-making behind it. The octopus isn't performing the same behavior every time. It appears to assess the situation and select the disguise most likely to work against a particular threat. That level of flexibility is incredibly rare in the animal kingdom. Making these transformations possible is one of the most sophisticated camouflage systems on Earth. Specialized pigment cells allow the octopus to rapidly change color and pattern. Muscular structures beneath the skin can alter its texture, creating bumps, ridges, and shapes that mimic nearby objects or animals. Combined with its highly developed nervous system, the result is a creature capable of astonishing visual deception. Scientists still debate exactly how much of this behavior is instinct and how much involves genuine problem solving. But one thing is certain: the mimicoctopus represents the culmination of millions of years of evolutionary experimentation. From transparency to reflection, from living light to biological darkness, every camouflage strategy we've explored has been leading here. To an animal that doesn't just disappear, it becomes whatever it needs to be. Our journey began near the surface, where transparent bodies allowed creatures to vanish in plain sight. As we descended deeper, camouflage became increasingly sophisticated. Animals turned themselves into living mirrors. Others generated their own light to erase their shadows. In the darkness of the midnight zone, some evolved skin so black it absorbs almost every trace of incoming light. Still others discovered that the color red, so visible near the surface, could become the perfect disguise in the deep. And at the end of our descent, we encountered creatures capable of deception so advanced that they can convince predators they are entirely different animals. Each of these adaptations solves the same problem in a different way. How do you avoid being seen? Yet, perhaps the most fascinating lesson is that there is no single perfect solution. Every camouflage strategy comes with limitations. Every disguise works only under certain conditions. As predators evolve better ways to hunt, prey evolve better ways to hide. It's an endless evolutionary arms race. And if the ocean has already produced creatures that can become transparent, create light, absorb light, and impersonate other species, one question remains. What other camouflage techniques are still hiding in the unexplored depths of the sea?